All right, let's jump right in. We are absolutely surrounded by tech that needs power, right? Our phones, our watches, our headphones, they're all thirsty for juice. But what if the best power source wasn't your wall outlet, but was, well, you?
I mean, just think about that for a second. A world where you're not desperately hunting for a charger, no more dead smartwatches right when you need them. What if our most important gadgets could just power themselves, just by being on our bodies?
But here's the thing. This isn't just about making our lives a little easier. It's a massive roadblock for technology. For you and me, a dead battery is, a daily annoyance. But as we're about to find out, for some people, it's a genuine life or death situation.
And this slide just lays it out perfectly. On the left, that's our world right now. Limited battery life, clunky power packs, and let's not forget, tons of e-waste. But look at that last point, high-risk surgeries. If you have a pacemaker, that battery only lasts about 8 to 10 years, and after that, you're looking at another major surgery just to swap it out. So the goal on the right isn't just some nice upgrade. For medical tech, it is a complete game changer.
So, how in the world do we get there? Well, by tapping into this amazing untapped power plant that we're all carrying around every single day. And researchers are working on some pretty mind-blowing ways to harvest that energy.
Okay, our first stop is maybe the most surprising one of all. We're not talking about motion, we're not talking about heat. This technique literally generates electricity from the air around your skin. Welcome to the crazy world of papertronics.
So Professor Suk-Hun Choi over at Binghamton University had this brilliant idea. It all starts with a special paper that literally soaks up humidity from the air near your skin. Then harmless bacteria spores that are coated on the paper get to work. You can think of them like a tiny biological dam. They split water molecules into positive and negative ions. This creates an imbalance, a gradient, and that generates a small but steady electric charge. It is literally pulling power right out of thin air.
And this quote really gets to the heart of the bigger picture. See, while some people are trying to build tech that lasts forever, Professor Choi is thinking differently. He wants to create truly disposable smart sensors. Imagine a smart Band-Aid that checks on an infection for a couple of days, and then you just throw it away without adding toxic e-waste to a landfill. That's the real genius of using paper.
All right, so we're going from disposable sensors on our skin to life-saving implants deep inside the body. For something like a pacemaker, you need a power source that is incredibly reliable. And really, what's more reliable than the constant, steady beat of your own heart?
The science that makes this possible is called the piezoelectric effect. Now, it sounds super complex, but the idea is actually pretty simple. There are these materials that, when you squeeze them or press on them, they generate a tiny electrical spark. It's a direct conversion of mechanical stress into electricity.
So researchers designed this really clever device, a hexafold piezoelectric energy harvester. Inside this tiny little thing, there's a small metal ball that moves around. With every single beat of the heart, the device moves, and that ball, bam, strikes the piezoelectric walls. Each one of those impacts is like that crystal getting squeezed, generating a little pulse of electricity. It's a tiny self-contained power plant driven by the rhythm of life itself.
And guess what? It actually works. In live tests on a pig's heart, the device generated an average of 367.2 microwatts. Now, that might not sound like a huge number, but here's the kicker. It's more than enough power to run a modern, state-of-the-art leadless pacemaker. This isn't just a theory anymore, it's a functional prototype.
But that brings us to the next massive challenge. A human heart beats over 35 million times a year. So, can a device that relies on something constantly hitting its walls survive that kind of relentless stress for decades?
Well, to find out, the team ran a durability test for over 35 million cycles, and the results here are fascinating. So look at the column for the non-impact area. The material is fine. You can see it's over 54% silver. Okay, now look at the impact area. Whoa! After millions and millions of hits, the silver content drops to almost zero. It was literally worn away. And that exposed the layers underneath, which is why you see the percentages for lead and titanium shoot way up. This wear and tear caused the voltage output to drop. So the takeaway is pretty clear. The concept totally works, but the next big hurdle isn't making the power, it's finding materials tough enough to handle collecting it for a lifetime.
So we've seen power from humidity in the air and power from the motion of the heart, but this third method, this one feels like it's straight out of science fiction. It harvests an invisible energy field that your body is putting out right now as you're watching this.
It's totally true. The human body naturally gives off low-level radio frequency energy, or RF energy. Yeah, you heard me.
We are all walking, talking, low-power broadcast antennas.
So researchers at Carnegie Mellon's Future Interfaces group cooked up this tech they call power over skin. They made these tiny light receivers that when you put them on your skin can actually capture this 40 megahertz RF signal and turn it into usable power. And it's shockingly effective. It can harvest up to 1.53 milliwatts, which is enough to run small sensors or even a Bluetooth device. And the best part? It works right through your clothes, which makes it perfect for wearables that are truly seamless.
Okay, so we've got 3 different, pretty incredible ways to generate power from the human body. So how do we weave all of this together to actually create that battery-free future we've been talking about?
So let's do a quick recap. You've got Papertronics, using humidity for things like disposable sensors. You've got the piezoelectric harvester, using motion for medical implants like that pacemaker. And then you have power over skin, using our body's RF emissions for stuff like smart rings or VR gear. Each method is perfectly tailored for a different job.
But this brings up one last, absolutely crucial question. I mean, generating power is one thing, but storing it in something that's soft and flexible and actually comfortable to wear, that's a whole different ballgame. After all, what good is a self-powering t-shirt if it has a hard, clunky battery pack sewn into it?
As researcher Trisha Andrew points out, normal batteries are the single biggest bottleneck here. They're bulky, they're rigid, they just don't last. The answer isn't a better battery, it's getting rid of the kind of battery we're all used to. Her team at UMass Amherst developed the perfect solution, a micro supercapacitor. You can think of it like a fast-charging, flexible little energy pouch that can be sewn right into any fabric. They use a special vapor coating process to make threads conductive, and then they stitch them into a grid that stores energy. It's a true smart fabric. Just imagine this woven into the sleeve of a physical therapy patient, powering sensors that give their doctors perfect data on the recovery. This is the missing piece of the puzzle, the link between generating body power and actually using it.
So what this is all leading up to is a future with technology that isn't just more convenient, but is also way more sustainable and deeply connected to our health. This is really the beginning of truly personal technology, powered by us, for us.
And that leaves us with one final, kind of wild thought to chew on. As our tech becomes powered by our own biology, that line between the user and the device starts to get really blurry. And it forces us to ask, what does it even mean when the machines we wear are, in a way, just as alive as we are?